Hello, everyone. Welcome to yet another episode of Risk Grustlers. We're taking a slight departure from our regular theme around understanding the stories of the people that we interview. And this is an episode that we're releasing sort of on public demand because we work with a lot of companies that are now using LLMs as part of their core application, which are customer facing. And in that context, and there's enough content out there in terms of what kind of risks such companies would face within their application and what mitigating controls should be there. And there's a bunch of content out there in terms of so the OWASP Foundation has released its top 10 version 1.0, which is fairly comprehensive. There's a NIST AI RMF framework as well. But the idea for us today is we just wanted to demystify it, simplify it as much as possible, and sort of put a framework around where to potentially get started. And our guest today is Walter. I don't think Walter needs an introduction. One of the most widely followed content creators in the space, has been writing about the space for a very long time. So Walter, thanks for being here. Thanks for taking the time. Uh, just to get started, right? So we see a lot of companies now using LLMs as part of their core application, and they're building utilities on top of LLMs which are customer facing. Now there could be two models to it in terms of the deployment. One is companies could be using an open source LLM, training them in house, and building applications on top of that. Alternatively, companies could be using a third party LLM like ChatGPT. So between these two scenarios, how does the model of deployment really determine what the risks could be? What do you see as the primary trade-offs there from the point of view of security and risk management?
Yeah, so great question. The traditional cybersecurity risk assessment of do you outsource your work, your data processing to someone else, or do you run it in an environment that you have more control over? That still applies. So all those considerations of, what are your vendors, policies with respect to vulnerability management, what are their endpoint detection and response capabilities versus your own capabilities. Those are all things that are still important when it comes to whether you're running a model in your own environment or in someone else's. There is an additional wrinkle when it comes to artificial intelligence technologies like LLMs. And specifically, that's what I would describe as unintentional training or unintended training. So that occurs when an organization submits data to a large language model or other sort of model that it didn't intend to, or maybe the security policy of that organization prevents or would prohibit an employee from submitting that type of data to a large language model. And then if that model trains on that data, it could potentially resurface that information either to the vendor itself or to one of the vendor's other customers in a way that could be damaging to the original customer in the first place. So it's difficult to understand exactly how big of a risk this is in terms of occurring. We definitely have some examples of companies that have unintentionally submitted confidential data to a third party artificial intelligence model, at least reportedly. So Samsung has reportedly submitted some confidential code and some meeting notes to ChatGPT. There was an article based on that. Obviously, they didn't confirm that, so it's hard to tell how bad that leak was. And then Amazon also reportedly, one of their attorneys identified some very curious or interesting responses from ChatGPT that very closely mimicked the some of the questions that Amazon asks during interviews, implying that someone may have entered that data into ChatGPT up front and trained it on those responses, making it more effective in replying to those questions. So really the key difference on top of the traditional third-party risk management issues would be that of unintentional training by the model. And there are lots of wrinkles and considerations and trade-offs that you alluded to. Happy to go into depth on those, but I'll stop there in case you have any more detailed questions.
Fair point, Walter. And that the point that you alluded to, which is uh, the unintentional outcomes are effectively the difference between because companies have been using third-party APIs forever now, and they've traditionally been part of the GDPR or CCPA disclosures as part of the DPA. But but the unintentional outcome is something which is an additional risk that LLMs would pose. And that's the reason why there's a fair bit of urgency around maintaining good risk management practices around them. But one follow-up question is, if I, as a company that's building a utility on top of an LLM, have the option of choosing between using an open source LLM and training it in house versus using a third party API of a different, I mean, of a third party LLM, right? So for me, as a vendor, how do I understand the trade offs between both the models in terms of risks? Is one riskier than the other inherently? And if yes, how so?
I would say no, one is not inherently riskier than the other. Each has its own characteristics and trade offs. So, for example, if you are relying on a third party API like the OpenAI API, you are going to be relying on OpenAI to maintain the confidentiality, integrity, and availability of the data that you provide to it. I know, for example, OpenAI has different policies when it comes to data retention, whether you're using the user interface for ChatGPT or the API. So the API, all data is deleted after 30 days, at least according to the terms and conditions. But if you use the user interface for ChatGPT, there's a much more vague data retention policy that says something like, OpenAI will retain it for as long as it is required for valid business purposes. So that I view that as being potentially indefinitely. So understanding the data retention policies of this third party vendor is going to be critical. And then also understanding what security measures do they have in place. I know that, again, I'm using OpenAI as an example. They have a SOC 2 Type 2 attestation. So they have had a third party audit of their security. But on the other hand, earlier this year, they revealed that some user prompt summaries or titles had been leaked to other users in ChatGPT. So that was, according to them, the result of a third-party library vulnerability. But still, as a user, that's something to be concerned about. You don't have as much visibility on how an organization is protecting your data when you're giving it to them and letting them process it. Now, if you move to the self-hosted model, which some people would call on-prem, very rarely are you actually running it on-prem. Usually you're using an infrastructure as a service provider, usually one of the big three, to
Exactly, because most of the companies that we've dealt with, they don't truly do it on-prem. If I'm an application developer, I would effectively host the model in my environment within my AWS or Azure account, and make it available via multi-tenancy to my customers, right? Which again is essentially making an API call, but just that it's hosted in my environment.
it's really just a question of how far up or down the stack or the continuum between infrastructure as a service, platform as a service, or software as a service you're going to be. OpenAI API being software as a service. If you're running, for example, if you download Llama 2 and you run it in AWS, then you're on the infrastructure as a service side. There are benefits there. For example, you can see the processing of the data with more granularity. You could potentially control. You have access to the model, of course. So if you submit something to it that you decided in retrospect you shouldn't have, you can know that. You could roll back the model potentially. But with that said, there are risks with this approach as well. For example, this presumes that you have the technical ability and know-how and resources to manage the infrastructure yourself. Are you updating the environments? What happens if the model itself, if the major vulnerability is identified in the model? You may get all the notifications you can handle from security researches and things like that, but you'll actually need to update to the latest version to patch these gaps. And then also there's a serious risk of misconfiguration. I know Gartner has a number that they've thrown out there. I'm not 100% sure where they got it, but they said by 2025, 99% of cloud security breaches will be the result of customer misconfigurations. So ensuring that you can manage your own infrastructure is really important to hammer down before you decide that you're going to run a model on your own. And I've seen very large enterprises, with billions of dollars of revenue, that they don't actually keep their environments up to date, and they have very complex change management processes that require a lot of sign-offs before they can roll an update. And while that's good from an availability perspective, there are some security concerns, because if there's a widely exploited vulnerability that's rapidly identified in a large language model or in the supporting infrastructure, you're going to want to move very quickly to patch that. And now it's necessarily going to be the case that a software as a service provider, where it's their job to run that in production all the time, they're going to know how to do that more quickly and more effectively, all other things being equal. So those are some of the security risks that you'll need to trade off.
Got it. So if I have to summarize broadly, again, this is very, very, very broad, but if you're using a third-party API, given the kind of resources that they have, it will be easier for them to continuously keep themselves updated in terms of maintaining hygiene security practices, which might be harder to do if you're hosting an LLM within your environment. But on the privacy side, we may entirely have to rely on what perimeters they define, what boundaries they follow. Oftentimes, the prompt could actually carry information into the LLM, into the model inadvertently, right? And just one follow-up question to that, just in terms of liability, if I'm using as an application developer, if I'm using a self-hosted LLM versus using a third-party LLM, do you see a difference in terms of what liability I would carry should there be an incident?
Well, I'd say that's going to depend on what your contractual and regulatory obligations are. I know there are some regimes or some contractual obligations that will prohibit hosting data with a third party, either completely or without notification or consent of the original data owner. If you have those requirements, definitely don't violate them. Make sure that you're following your contract.
I think there's a fair bit of lack of clarity in terms of how different regulators, I mean, how different countries are reacting to the use of LLMs, particularly third-party LLMs. It's a little fuzzy right now, and probably I would say work in progress.
Yep, 100%. So I would say if you have explicit contractual or regulatory requirements, then definitely follow them. But I would say, barring that, your key concern should be preventing the loss of data, confidentiality, integrity, and availability. So whatever you think is the most effective way to do that within the bounds of legal and compliance requirements, then go with that. That's what I would.
Got it. Got it. Now, switching gears a bit, Walter, and deep diving a little bit into the second use case, which is essentially me as an application developer using a third-party LLM to build a utility on top of it and delivering it to my customers. Now, there is a fair bit of content out there. There's the OWASP top 10, which is now being released, version 1.0, and there's the NIST AI RMF framework also. But I can see why it can get a little overwhelming for most of our viewers, most of the companies building utilities on top of LLMs. So if we have to sort of make it very foundational, sort of a 101 kind of a discourse on this, what would you consider as the top 5 concerns or risks that people should look out for? And if you could just talk about some examples around that and what would be the mitigating controls, that'll be helpful.
Sure. So for the top 5, I would say number 1 is direct prompt injection. And then number 2 would be indirect prompt injection. Now, I'm happy to talk about the difference there. Number 3 would be the unintentional training problem that I described, especially with third-party services. Number 4 would be data poisoning of the model itself, and then number 5 would be privacy regulation violations that are specific to LLM usage. And I'll talk about some of how the existing requirements and laws out there are potentially a little vague, and how organizations might not even be sure how to comply with some of their requirements. So those would be my top 5. Happy to go in depth, starting from the.
Absolutely, let's go top to bottom, and we'll make these available in the transcript of the conversation for our viewers to look at it offline as well. But would love to go through some of the examples.
So prompt injection, more broadly, is probably one of the stickiest problems there is when it comes to LLM security, because it's not clear that this is a solvable problem entirely. And again, you're always going to be dealing with risk and balancing that against the reward. So that doesn't mean you can't use LLMs, but it's not clear how this problem is going to get fixed. And direct prompt injection is kind of the easiest to understand, because there are tons of examples of this. This is you telling the model to do something, and it's executing or responding to your command in a way that neither you or that you as the developer or host of the model didn't intend the model to react. So tons of examples, people going into ChatGPT, asking how to commit crimes, asking it to create malware, asking how to hack into certain types of systems and then it responding. OpenAI has created a bunch of safety layers that have made the model a little more restrictive and potentially even less performant. And people still manage to jump these boundaries through direct prompt injection, and that assumes that the user itself is malicious, so the user is attempting to violate the constraints of the model. And unlike SQL injection, there's not really a clear way how to resolve this. With SQL injection, you can apply validation, you can apply certain types of rules, since it's a very, in the end, it's a structured query language. So there are a finite number of ways in which you can make those queries, and you can, with enough hard work, apply the right guardrails. With prompt injection, it's not clear that there's a way you can do that, because one of the benefits of large language models is that they accept and they provide unstructured output. So that is really the number one problem in my view.
There could be two, three situations there, right? So one would potentially be the situation where somebody inadvertently injects PII or PHI or card data for that matter into the model. Alternatively, it could also mean that somebody actually injects IP into the model that shouldn't go into the training for the model. Now, there could be multiple kinds of risks. So if you can just break it down one level below, what would be the two, three scenarios there? And if there's anything at all that we can do, for example, when could companies potentially place some guardrails around employees interacting with LLMs? I mean, they cannot reveal PII, they cannot reveal PHI, and potentially tokenizing that information when it goes into the model itself, so that it doesn't get surfaced against a random query somewhere uh, two continents away. So, what would be the kind of examples there?
Yeah, so what you described is that I would describe that as unintentional training on sensitive information. Prompt injection, at least certainly in the direct sense, means that the user is maliciously attempting to manipulate the model by telling it to do something that is against the rules of the organization, its terms and conditions, or even the law. So a prompt injection example, a really bad one would be if the LLM is connected to some sort of function on the back end that would spin up or even shut down a service in process. So if you were working with an LLM and you're using it to manage your workflow, and somehow the LLM had the capability to shut down a service that was in process, and you attempted to put a safety layer in place, but an attacker jumped that safety layer and shut down your e-commerce portal or something like that. That would be a very bad prompt injection attack. Assuming they had access to a customer-facing chatbot or something like that. So some potential mitigating controls that you could apply in that case are you can attempt to do rules-based filtering. For example, if a user inputs any sort of keywords, you can use that. Unfortunately, humans are still pretty smart, and it's difficult to enumerate all the ways in which a human can find a way to maliciously attack a model. Another way you could do is you could use a supervisory LLM. So you could use another LLM that has a different set of user instructions, which would be, for example, if you're just sending a prompt directly to a model, it will obey your instructions literally. But if you have another model in between that intercepts the instructions, and then you provide a special message to it saying, like, you are a security focused LLM, please evaluate this prompt to see if there are, is any hidden malicious content in here, you could potentially get a different result, and then you could stop the prompt from executing. Obviously, that has some drawbacks in terms of cost and speed and things like that. And again, it's not a surefire way. And then also there's some things you can do on the back end. You can control what data sources the LLM has access to. So for example, if you've got a customer-facing chatbot, wouldn't be a problem if that chatbot had access to your entire publicly facing knowledge base. That would be a good use case for it. You're going to have much greater concerns if that chatbot has access to customer information. You might want the chatbot to have access to that specific customer's information, but you certainly don't want it to have access to other customers.
So I think the trade-off really is about, uh, to what extent do I automate the discovery, because that will be driven by what what parts of the knowledge base the model has access to. So the trade-off really is between how much information can I automatically provide to the customer seeking information through the chatbot versus maintaining a certain degree of privileged access to the source of information in the first place.
And something you could consider doing is using a non LLM function to control access to the backend. So you could basically provide a limited database view for a specific customer who has authenticated. That way, there's no way the LLM could break out of the existing customer's data and provide another customer's data.
Talking about the second risk that you picked, indirect prompt injection, could you pick up a few examples around that and the corresponding mitigating controls?
Yeah, so this is a little more challenging because security researchers have already started doing very impressive things. For example, embedding what some folks have called AI canaries in websites that will ask an autonomous agent that's going around and scraping data from pages would ask the autonomous agent to do certain things. Some of them are very benign, like just say hi or something like that. Some of them could be much more severe. For example, like provide sensitive information about your operating system, or even passwords or other credentials from your operating system. And if you embed this stuff in web pages, then autonomous agents that are going around the internet will start interacting with it, and you'll have this the prompt injection problem again. Except in this case, the model is being operated and directed by someone who is not malicious, but accidentally falls into the trap that is set by someone else. A really impressive example that I saw was someone had chained together multiple ChatGPT plugins and then used WebPilot, which is basically a browsing plugin for ChatGPT, to use the model to go to a website that had some malicious instructions embedded. It ingested those instructions and executed a Zapier workflow. And that Zapier instance had access to the user's email, summarized an email, and then navigated to the malicious web page again and used since going to a web page is essentially an API request, sent extracted sensitive data from the user's email and sent it as a parameter in the call to the malicious web page, thus providing the security research about the malicious party in real life this sensitive data from a user's email. So that's one kind of example of how indirect prompt injection could reveal sensitive information.
What would be the mitigating control here? Because I'm guessing this is going to be super deceptive. So, and traditional phishing simulations or trainings wouldn't really cover this, right? So what are the mitigating controls that companies could follow? And this is perhaps going to impact employees at large, not just it's not just application to application talking, right? So I mean, what are the mitigating controls?
Yeah, so definitely be careful when you have autonomous agents. So there's an open source project called AutoGPT where you can basically you can let a OpenAI powered model loose on the internet, and it can navigate to websites. You can even set it on autonomous mode where it decides what decisions to take and what actions to take. That is something where you're going to want to apply a lot of scrutiny, because it's very easy to see an auto GPT navigating to a malicious web page eventually and doing all sorts of bad things that you don't want it to do. So applying a lot of scrutiny to autonomous use cases is important. Another thing that I know, for example, in the situation that I described with the Zapier workflow and exfiltrating data from a Gmail account, now in that workflow, OpenAI has required the user to affirmatively consent as part of the workflow to the data processing. Now, that's not a perfect example because people will often just click yes when they're prompted to give permission to a software tool. So that's not a perfect fix. And then also applying safeguards and guardrails to function calling, especially focused on that whenever the LLM has the ability to call functions or trigger other business logic, and making sure you have the right segregation of duties or authentication prior to doing that. That would be an important control you could apply.
The risks associated with indirect prompt injection, given our current state of understanding and our current state of defenses, would you consider this predominantly an accept, mitigate, or a transfer category risk?
Yeah, I would say you would probably want to avoid this most of the time because The use cases for autonomous LLMs are, they're very
Fairly preliminary.
powerful, but not well defined, and there are just a lot of gray areas. You might consider, certainly mitigating it by using the tools that I mentioned, and then you could consider accepting some of the residual risk if your use case requires it. If you have a trusted list of web pages, for example, if you're only navigating to, to the Google domain, you can be pretty sure that there are no malicious scripts embedded. You can't be sure, and of course, maybe somebody could plant one there, or an insider could plant one there. But you could reduce your risk by limiting the websites to which you navigate using an autonomous LLM.
Got it. And maybe over time, there's a known directory of websites which are identified as malicious, and companies could potentially block access to those websites in the first place.
Yeah, having a do not enter sign on the bad ones would make sense, but it's pretty easy to spin up a malicious website.
Of course, I mean, and attackers don't have to deal with bureaucracy, so they can do it pretty quickly. All right. So the third risk category that you picked was data leakage due to unintentional training. Could you just explain that a bit more?
Yeah, so this is the scenario you described earlier, where an employee unintentionally enters either personally identifiable information or credit card information or credentials, for example, into a large language model. And this risk would be heightened if it's controlled by a third party, because kind of clawing that data back is much harder after the fact. It might not even be possible. And then that model could potentially regurgitate that information or something like it to another user. So from a privacy perspective, if you enter your social security number or someone else's social security number into an LLM, ChatGPT has some safety layers in place, but as we described, those can be circumvented. Or it could potentially learn about an individual, learn information that the person in question wouldn't want learned by an LLM. So that's one potential downside. Another one is more on the confidential information, intellectual property side. If you enter a trade secret into an LLM and the LLM trains on that information, you might have just solved a very difficult problem that your competitors weren't able to solve by themselves. You might have just solved it for them. And if you train ChatGPT how to take a certain approach that it didn't know about, now it might know about it, and you might have basically shared the wealth in a way that you don't want to from a commercial perspective. So those are the primary risks from unintentional training. And when other people can access, or other entities can access, the same model that you're using, the risk is heightened there.
Got it. And what would be the potential mitigating controls there?
Yeah, so some mitigating controls, certainly at a policy level, you want to have a clear framework for what type of information employees can enter into certain types of models. And StackAware, my company, has a free template that people can use. And that's going to be a business decision based on the model in question and what the organization is trying to do. You probably want to prohibit entering any sort of protected health information, personally identifiable information, into a third-party model unless you have certain assurances, certain controls there. And you also want to be careful with confidential information. That doesn't necessarily mean you can never do it. For example, the Azure OpenAI government service just stood up, and that's certified for certain types of sensitive information for government users. And they have, I believe, they have single tenant setups there for the customers. So it's potentially permissible that you might enter into that information into certain types of models. You just need to be clear about what is acceptable where. So the policy would be one thing. A second thing you could do is apply pre-processing to data that's being entered into the model. So I created an open source library called GPT Guard, which essentially identifies names, API keys, passwords, IP addresses, things like that in information, and then automatically redacts it before it's passed to the OpenAI API. And then it basically tells the model that you've replaced certain things with placeholders so that it doesn't get confused. And then it provides back that information. It reappends the sensitive data, but only on the user side so that the model has never seen it. There are also commercial tools out there that do this. And then kind of the most effective way, or the most effective control, would be hosting the model yourself, in which case you would be able to roll back the model or understand if it's been exposed to sensitive information. That's not a perfect solution though, because if something slips.
But that could also be cost and resource prohibitive, right? I mean, it's sort of companies in very early stages with probably no external funding could find it hard to maintain the resources and the infrastructure required to maintain a model in house,
Yeah, it's
especially build security controls around it.
right. And you might be exposing yourself to kind of more traditional cybersecurity risk if you're doing that.
Exactly. Because the basic hygiene security controls might not be in place.
Right. And also if you're using it, say for example, you're creating a customer chatbot and you're hosting it internally and you accidentally train the model on your proprietary information and it's customer facing, it's possible that a customer could recover that proprietary information from that publicly facing chatbot. So the same controls apply. You just have more ability to kind of understand what's happening with the model.
Okay. You mentioned if you stack away resources, which we'll share the links to that if they're available for free as part of the follow up for this conversation. Now, moving to the next one, which says data or model poisoning. Right now, how is could you just make it easier to understand how is it different from direct prompt injection and unintentional training? So how does it manifest typically?
Basically, prompt injection and unintentional training assume that the model itself is intact, or it begins intact, or it hasn't been corrupted in any way. But data or model poisoning is that it assumes that the opposite is true. In that situation, the model, it's either you began with you were there was a bona fide actor that was creating a model, but the data on which it was trained was intentionally poisoned or corrupted in a way that changes the operation of the model. So that would be data poisoning. An example that I've seen on Hacker News was if I were a software developer and I want to really help my career, I could just spin up thousands and thousands of blog pages saying how great a developer Walter Haydock is, and with no backing to it, and I could just put up all these pages all over the internet and assume you have an autonomous model that's training on all this information, and then 5 years from now somebody's using this model to interview me and they just ask, describe all the good things that Walter Haydock has done as a developer, and it makes up all these fake things and they give me the job. That would be an example of data poisoning.
That's actually a very benign example, relatively harmless, but imagine what people could do when they're trying to do political propaganda, for example.
Of course. And then also you could potentially train the model to operate 99% of the time in a very predictable way. But in the 100th time, given a certain command, the model would pull all the credit card numbers out of your database and send them to a certain endpoint or something like that. I mean, that'd be hard to engineer, but high difficulty, high payoff type attack.
So we're talking about a situation where the credit card information was fed at the time of feeding the training data, not as part of the user generated prompt.
No, I'm talking about if, say, you are developing a model that processes credit card information. For example, you intend to use it internally. You're looking for fraud or something like that, and you built the model yourself, and you built it on all sorts of prompts and outputs. For example, you'll show the model a bunch of situations that are fraud and a bunch of situations that are legitimate. But if the attacker somehow slips in a couple or a whole set of data that tricks the model into doing something that is unintended, and if the model has access to your underlying database, assuming you have access to credit card numbers or something like that, it might appear to function normally 99% of the time, but potentially it's making post requests with that sensitive data to a malicious endpoint or behaving in unanticipated ways. Whereas the operator of the model is a legitimate user and has a legitimate use case, but somehow incorporated poison training data into the. And then the second kind of option would be if the person training the model itself was malicious and then somehow uploaded this model into the water supply, into the supply chain of another organization. And there's a company called Mithril Security that they just gave an example of how to do this. They almost uploaded a poison model into Hugging Face they obviously disclosed it before doing any damage. But in this case, this model would do something like tell you that the first man on the moon was Yuri Gagarin, who's a Russian cosmonaut, who's not the first person on the moon. And that's just a benign example, but it could do other things like I described earlier. So in that case, the person who built the model in the first place is malicious and somehow seeds the model into another set of workflows for other organizations.
So the Yuri Gagarin example is actually it was pretty popularized. Uh, we'd seen that at Hugging Face too. So now the fifth one, which is essentially around privacy regulation violation. Now this is my favorite because this is not just, I mean, this is an actual business risk too. You could be building an application on top of an LLM, and today you might comply with local regulations abundantly, but the regulations themselves are very fluid in nature, and different countries are reacting very differently to the use of LLMs, and a lot of these regulations are actually evolving. They're very fluid in nature, right? So how can companies circumvent that? How can companies minimize their business risks? And is there is there a sort of a base case framework that companies should stick to? How much do the current ISO 27701s and the 27018s of the world really cover these use cases? And what should companies be looking to do to de-risk themselves to the extent possible from the fluctuations in local regulations around the use of LLMs?
Yeah, so I'd say the existing compliance and legal frameworks, some of the ISO series that you mentioned, whether it could be on the legal side like GDPR, CCPA, they are they are high level and uh, they don't always adapt quickly to changing technology. And there are new regulations that are surfacing. For example, like the European Union AI Act could potentially see passage pretty soon, which would ban certain types of artificial intelligence applications. So companies are going to need, if you're going to use AI, you're going to be assuming some risk, frankly. And the best way to proceed, specifically from a privacy perspective, would be to collect and process the minimum amount of data possible. For example, I see all these intake forms all over the place, different businesses, even in medical settings, that collect all sorts of ungodly amounts of information. And I'm pretty sure, having been and worked in software companies, like a lot of that information isn't necessarily being used or processed. Companies make all these recordings of meetings, even of customer calls, things like that. Some of that information might potentially qualify as biometric processing if you've got videos, that you're analyzing for sentiment and things like that. And that could trigger some enhanced requirements under GDPR. It could also, if you're doing it in public places, that would be eventually forbidden under the EU AI Act as is currently contemplated. So collecting the minimum amount of information, especially personal information, as is necessary to accomplish your objective, that would be my primary suggestion. But there are still going to be lots of gray areas, and unfortunately, we're going to see what I call regulation through enforcement in a lot of cases, where a regulator decides that something is not allowed or is prohibited by current law, and we only find out about it when the company in question gets hit with a fine or some other sort of punitive action. So it's going to be dynamic, and companies will need to react quickly because things are gonna change fast.
And picking on your first example, Walter, what are some of the ways that companies can actually exercise control over what nature of information they actually collect and classify information automatically as useful versus not useful, or not necessary rather?
I would look at customer onboarding workflows, for example, and just look at all the forms that you have customers fill in. For example, I see lead magnets that require, name, phone number, position, what state you live in, what zip code you live in. A lot of that stuff probably isn't going to be used that early in the marketing funnel. So, I'd say just collect an email if you can. You may need to collect certain type of residency information for compliance purposes, but don't over collect, certainly, because every marginal piece of information that you're using, it may have benefit from a business perspective, but you don't want to collect it if you're not going to immediately use it. So look at your intake forms, your processes, and then also look at all the different places that you're storing data. If you're duplicating data, that's that from just an operational perspective, that's probably not a good idea. But also from a security perspective, if you've got two different places where you're keeping sensitive data, you should probably go down to one and have backups of the first one. Have be able to roll back if you need, but don't have two different versions of it floating around there. And then especially email, people are it's very difficult to control what is put into email. So being very careful there, and always using a hyperlink to an authentication controlled source, like a Google Drive link or something like that, or a SharePoint link where you can revoke access on the back end. That's a good way to reduce the amount of data that you have collected and sent around. And then also, a lot of these emails could potentially be fed into LLMs in the future for all sorts of purposes. So if you're controlling the sensitive information that gets into them in the first place, then you'll reduce the privacy risk on the back end.
All right. These are all the questions I had, and in the interest of time, we'll keep the podcast short and simple. But what we will do, Walter, is that we'll share the resources that we alluded to in the conversation as part of the comment section down below, and we'll keep the house open. We'll keep the conversation going for people that have follow-up questions. Uh, and to the viewers of the podcast, please leave your questions against this video. Reach out to me, reach out to Walter. Would be very happy to answer questions. This is an area that we are super passionate about, and we're tracking developments very closely. And we want to keep it just the right amount of dumb so that people can really make sense of what to do and not get lost in the jargon and all the esoteric language that's really being proliferated out there. But thanks again, Walter. Thanks for taking the time. This has been super helpful.
Yeah, thanks a lot. Really appreciate you having me on.